Well, hello, everybody. I'm very excited that we got our video back because, they don't want to go to all that work to make a nice little video and then have it not show up. So today, let's see, we are doing KBEI, and we do this show on a monthly basis on the last Tuesday of the month. And, we like to, sorry, I'm getting some background noise. I'm not really sure why. I don't know what's going on. Sorry, I'm actually hearing myself on a 5-second delay. Hopefully that will be better now. All right. So like I said a few minutes ago, if we don't have a couple of technical difficulties, we're afraid the show is going to go terribly. So that works out well. So I think I had a Twitch stream running in the background that was off mute, which is always annoying. But all right, so today, so just by way of introduction, I'm Langdon White. I am a faculty member at Boston University, and I used to be a Red Hat employee, focused primarily in my last year or so on actually doing another Twitch show, which we'll be doing this last episode on Wednesday of this week. Which I will be rejoining to kind of, check back in and say hi and all those kinds of things. That was about containerization and OpenShift. But my primary focus was actually on working with the field and developers around serverless, Knative, et cetera, and event-driven architectures. And so that's a little bit about me. And my co-host today is Josh Wood, who you've seen in prior shows. And do you want to introduce yourself real quick?
Sure, Langdon. Thanks. I'm Josh Wood. I'm currently a developer advocate at Red Hat. My focus is on OpenShift, and particularly interesting for today's guests and the project that we'll be talking with them about, Kubernetes operators and how they work at the core of OpenShift to deliver auto updates and management of foundation software on the platform, and where we see a lot of people building cool new stuff sort of in the space and on the scaffolding that the operator pattern or concept and the toolkits around it represent.
Nice. It's always nice when you can have a tool that does its own installation and kind of updating, right? Because then you don't have to figure out how to get it right. We've celebrated this in the Linux world, right, with package managers for a long, long time, I don't. It's so painful to use something like Windows where you have to go manually update things all the time. Although it's getting much, much better. So today we have on the show Lalith Suresh. Did I say your name correctly? I hope.
Yeah.
All right.
Yeah.
So, if you wanted to quickly introduce yourself, I meant to check before the show, but feel free to say it again correctly, and I will try to.
Sure. Yeah. So, hi everyone. I'm Lalith Suresh. I'm a senior researcher at VMware, where I primarily work on cluster management, basically looking at new ways to program cluster managers. And the focus of this talk would be some of the work I've been doing on testing cluster managers. So, yeah.
So the emphasis was on the wrong syllable, is basically the takeaway. And Michael Gasch, do you want to introduce yourself?
Sure. Hey, everyone. Thanks for having me on the show. I'm Michael Gasch. I'm based out of Germany. I hope my audio is good now. We had some technical issues, as you said earlier. And as of today, I'm still with VMware, but on September 1st, I'll be rolling into a new adventure as part of my career. I'll announce on Twitter, I think maybe tomorrow or so. So stay tuned and follow me on Twitter if you're curious where I'm headed to.
But the Insider show, don't we get the secrets now? No, I'm just kidding.
And I forgot to mention that at VMware I worked on event-driven systems as well, Knative, serverless, and early on Kubernetes. And I tend to build prototypes and help our customers with large installations, including OpenShift as well.
Cool. And so if you want to follow both these folks on Twitter, you can find their Twitter handles as well as ours on the notes on the show on Cube by Example. But why don't we get right into it? And so the first thing we like to ask our guests is, kind of what got you into open source? What was the driver that made open source the thing you wanted to kind of work on? Whoever wants to go first, feel free, and we'll try, hopefully, not to step on each other.
Mr. Suresh, you
Yeah, I can start. So yeah, this goes back to my undergraduate days when I was first introduced to things like Linux and FOSS, and I used to attend a lot of these open source conferences back back home during that time. And then for me, like sort of the first time that I started becoming a contributor was with the NS3 project. It was it's basically a network simulation software heavily used in the networking research community. And then I joined the Google Summer of Code program with them, and that was sort of my launching pad into open source. And that's where I would basically say I was trained in writing real world software, right? So then I was a maintainer for a while, but then that's kind of where I got introduced. And then after that, kind of once you get started, it's easy, right? Like contributing to more projects, and it just rolls after that. But it's that first
right. Once you're like pulled in, you can't. It's hard to escape again. Yeah. So what brought you to Kubernetes? Kind of along that route.
So that started when I joined VMware actually, and so I work on distributed systems and networking, and at the time I was looking into things like fault tolerance, and then I started looking into things like how do you there's a lot of reinvention of the wheel in cluster management, right? Problems like
software,
failure, or like I don't know, say rolling upgrades. All of these things, the concepts are very similar, except you keep reinventing that wheel in every new system that we come across. And in one particular project where I was looking at, how do you write things using declarative programming and stuff, we were like, hey, we have this cool technique. We are sure it makes it easier to build certain things the second and third times. So why don't we try building a Kubernetes scheduler on top of all the other things we've built, right? And that was my first introduction to Kubernetes. And that's where I also, was talking to Michael a lot, because he knew a lot of the Kubernetes internals that at the time I was sort of running into, right? Like, why is the Kubernetes API behaving this way? Michael, help me out here, right? That's kind of how we got started into this sort of rabbit hole that led to Sieve eventually.
That's cool. Yeah, I mean, as you say, I one of the things I think was hilarious. I saw an OSCON talk many years ago. That was basically everything's already been invented by 1979 in software, and then we're just kind of redoing it better and cleaner and faster, since then, in a lot of ways, right? The cloud is mainframe on steroids, right? So, it just keeps going and going. So, Michael, go ahead, Josh.
Just as an aside, Langdon, when you bring that up, I'm wondering what it was that was invented between 1969 and 79 that I'm not thinking of, because I would actually
push the date. I could be misremembering the date, to be clear.
All right. Michael, tell us, instead of me diverting us down other paths into history, tell us how you got your start in open source, and then especially you could do a beautiful job like Lalith did of dovetailing it right into the Kubernetes experience.
Sure. Yeah, exactly. Because I also had like two entry points into open source. The first one was 2002, where I was part of a trainee program at a research institute. And there they were all doing Linux stuff. And I was tasked to migrate the Windows NT domain system and file services towards Samba, Samba the file services. And by the time Samba was moving from version 2 to version 3, and it was an alpha one, so I was like, there was a lot of bugs and issues. I was starting to use it and give feedback to the great Samba community, and this was kind of my first open source adventure, include like Samba and OpenELTA. And then I built a lot of systems on Linux, a lot of file services, parallel file services systems. And then many years later, in 2015, I joined VMware. And I was going through an onboarding phase at VMware, doing all the hiring stuff. And I saw a talk from somewhere, from some of our colleagues talking about Mesos and Kubernetes. And I got somehow intrigued. Even though my role did not require that knowledge by the time, I was just fascinated by the technology and all the stuff that they were working on, especially like building a distributed operating system or kernel. And so that got me into Kubernetes. And then I focused primarily, because Kubernetes was growing a lot, I primarily focused on the resource management aspect, like scheduling, the Kubernetes scheduler, and how all these resource semantics play into it. I was lucky to give a talk at KubeCon as well about resource management. And then a bit later, I met Lalith. And it was always so fascinating because he also was working on a lot of stuff that earlier that I started to touch on. And but by the time he was working on it, it was often like proprietary, like all special frameworks for like large scale institutions. And so we met, and I was like, okay, maybe we can use Kubernetes, or we can use Istio, or some other open source stuff to use your idea and just make it more widely accessible and building on standard and open technology. And that kind of built a great relationship between us. And I always enjoyed it because he's very, very knowledgeable, especially about distributed systems. Just Google him up and you will find a lot of amazing papers, quoted papers. And so we got into Sieve. Like, I'm not jumping the gun here, but just this funny story how we got into the Sieve work. Because if you look at what Sieve does, it's very, very researchy. There's a lot of knowledge and background which goes into Sieve to make it do whatever like we intend to do. But at the same time, I was working on an etcd article because I was fascinated with etcd as well, and etcd is very important for Kubernetes, right? So I was working on this blog post about Kubernetes and etcd, and how the informers work and the controllers and all these patterns. And I was writing this article, and Lalith called me and said, Michael, we have a question on etcd. Maybe you can help us. I was like, this is great, because I was just literally typing the answer to your question in, the unreleased blog post back in I think it was 2 years ago, maybe.
Yeah.
So,
that was
and so that was
a year-long call where we were just diving through the code and just confirming what we were finding was the same as what you were writing about right now at that time.
And this was a very, very funny coincidence. And so this got me also into collaborating and working a little bit on the Sieve work. But the main, the brain is Lalith and Zhedong on the work, definitely.
That's awesome. So one of the questions, so I kind of put back to you too, is so why is kind of doing work in the open source world, better or more interesting or whatever than kind of the alternate places that you might have done development work?
I mean, for me personally, especially coming from sort of like the academic half of me, right? I think it's one of the best ways to learn how real world software works. It's right out there, right? Like, you don't have to. I really credit a lot of my education in computer science to open source, right? I never had to wonder what these concepts in the books meant when I could just look at real world software and see how it's actually implemented, right? Like, whether it's the JVM or Python or whatever, like Hadoop, all of these things are right out there, right? So there's always that aspect of open source that appeals to me, right? There's all these widely used software that we can actually see exactly how it's coded, right? We don't have to guess. The other aspect of it is just it's just easy to get people on board and collaborate, right?
Mm-hmm. Yeah, totally. It's interesting. My experience in a university, though, is that they a lot of students are unfamiliar with open source, and I find it kind of mind blowing. Because like when I was a college student, I was always looking for things that were cheap or free, right? And if nothing else, right, you get that advantage of open source. And so, one of my kind of quote unquote missions since I joined academia is to try to make open source more available and more prevalent amongst university students. So let's move on and talk about Sieve. This is one of those words that I learned from reading, so I pronounced it Sieve for a long time. But can you tell us a little bit more about the project? Like, where does it come from? What does it do?
Yeah, so the genesis of this project was another project, like I said, where I was trying to build a Kubernetes scheduler, and I was running into all these little quirks with, building just one piece that runs in a larger distributed environment, right? So every time I get some kind of stale input from the API server, or there's a sort of some kind of jitter in the network or lag or something like this, it turns out that these very small interactions with the environment would basically break my code, right? And at some point, and every time I remember, I would keep going to Michael, I was like, why is this happening, right? What am I supposed to do? And then he'll tell me about some pattern I was supposed to use, and then I'm like, okay, fine. And so after that project ended, I was like, okay, if it's, I don't know, if it takes two of us to write this, right? I can't imagine this is going to be, bug free anytime anyone writes it, right? So at the time, it was also this thing where I would see all these papers on, like trying to find automatically finding bugs in distributed systems was a hot topic. But I always had this frustration that, yes, you can build something for one system, but it's not broadly useful after that, right? And so I then met the rest of the team at a conference I was attending. So this is Tian'in Zhu. He's a professor at UIUC. So I ran into him and I pitched him this idea that, like, hey, look, I've been programming a bit in Kubernetes, and it seems like it's very hard to write correct software there, right? So, write these correct controllers that, no matter what kind of external input they get, they'll still do the right thing and not do anything goofy. Right? And he's an expert in reliability and testing and so on, and that's kind of how we clicked right there, and we teamed up. And his student would intern with us the next summer. That's Shudong. He's the lead PhD student behind this project, pretty much the star of the show, I would say. And that eventually led to Sieve, basically, right? Like, it was a very organic process. And at the time, like, Michael was also looking into things like the list watch and all of those, the details around that. And I don't know, that's how the whole team got formed. It was very organic, I think. Yeah.
And Michael, can you tell us how kind of you felt like you got involved? Like what drew you to the project?
Yes, so I because I already knew Lalith, and almost everything that he did or wrote about got famous in one or the other way. At least for me, like, fame is relative, but for me it was always very interesting. So I kind of followed his work, and I also spent a lot of time with him. And we were like just having lunch and sharing ideas. And so that's why whenever there were like Kubernetes questions or debates around some of the stuff, how Kubernetes works, as Lalith already said, we just hopped on a Zoom call and we were chatting about it. And coincidentally, there was this time where Zhudong and Lalith were having questions about how etcd, some of the semantics that etcd provides to Kubernetes, like for consistency semantics, and also how the informers then work in all these controllers. And as I was writing those blog posts about etcd, I was very familiar with the etcd code base and consistency semantics. And Lalith had this one question about the linearizability guarantees in etcd, and whether it provides like a logically and monotonically growing order of events or changes in the system. And I was just literally writing that paragraph in the blog post. And so I said, yes, it's there. It's a number. It's just a counter which goes up, the revision in etcd. And he said, this is great, because we need that in order to make some assumptions about the work that Sieve is doing. And so and then I was asking, okay, so what is this project all about? And we started working on this, and I gave more input, and I did some of the reviews in the paper. But again, I was more like an advisor from the outside for the work, and Lalith and Zhudong did the main heavy lifting.
The other bit is that, like, for everything we find, Michael knows at least 15 issues on the Kubernetes GitHub that we can actually reference. So that was the other. Yeah, so he was always our bridge to the community, I would say. Right? Like, he was more of the insider than we were at the time, I would say.
Well, I mean, sometimes being on the outside helps.
Yeah. Yep.
Interesting, and right, like it gives you a different perspective, whatever. So that's pretty cool. So let me just kind of ask a little bit more of a background question. So, like, I come across the project. What do I want to use it for? What does it actually do for me, as kind of a deployer or an application author?
Yeah, so the main target audience is controller or operator developers, right? Let's say you want to write, say, a Cassandra operator, and you'd go through, I don't know, you would use the operator SDK, or you'd use you might build on things like controller runtime, and you're going to write some code that maybe it monitors some kind of custom resource in Kubernetes, and then it takes it does some workflow depending on changes that it observes to these resources being created, updated, or deleted, right? And now this code that's running, like whatever, this reconcile loop that's running somewhere in your cluster or maybe outside the cluster, is just one entity in a large distributed system, right? And there are other independent actions happening, and at the same time, you can have things like failures and network partitions and all these other kinds of hiccups, right? And the tricky bit with writing this type of code is that it's very hard to test how your system will behave under. It's very hard to know how it will behave under any failure scenario, right? For example, like most code bases that we looked at aren't testing for what happens if you crash after every interaction with the API server, if the controller crashes after every interaction with the API server. But Sieve can basically do these type of tests automatically for you. So you give us some tests. We currently have our own little way of writing these tests, but it could very well be the E2E framework or something like this, right? But you give us some tests, and what Sieve will do is it'll explore many executions where it introduces failures in these tests. And what Sieve can do is that it'll automatically be able to flag when an execution where it introduced a failure actually produced a different result than failure-free run. This is one of the other innovations in Sieve, basically. It can do that diffing, and then it'll tell you that, hey, look, I found some executions where I introduced a failure, and it turns out that the cluster looks a bit different than it did before, or it went through some steps that it wasn't visible in the failure-free run, right? So it can actually do this type of reliability testing for you. Yeah.
I gotcha. So in a sense, it could have been a member of the Simian army, like Netflix's Chaos Monkey, etc. It's kind of in the same vein, right?
It has that.
Well, which is actually a question I wanted to kind of at least run through quickly as we get into Sieve and what it is if I were telling someone else about this project at a high level, what kind of testing does it do? Like, would I refer to this as chaos testing, or like, can I put it into one of those pigeonholes that we kind of use as a shorthand to talk about like what surfaces we're testing and what techniques we're using?
Yeah, so chaos testing tends to be something that you would run in production live, usually. This is not how you would typically run Sieve. It's meant to be a development time testing tool, right? So you can think of Sieve more as another layer of tests that you would run, say in your CI platform or something like this, right? On a cluster of machines where this just runs, I don't know, once a week or something like this, right? It's more expensive than a typical unit test or integration test, because we are actually, for each of those tests, we're running many tests, right? Where we're introducing all kinds of failures. But one key distinction between chaos testing and what Sieve does is reproducibility. If Sieve finds a bug based on a fault it injected, you basically have what's called a test plan. It's a self-contained file that Sieve runs, where it knows that, okay, it's waiting for exactly this event to occur in the API for it to pause the controller and inject a particular type of failure. Like, it knows all of that is encoded in a file. With just that file, you can reproduce exactly that execution over and over again, right? So that's how it really differs from chaos testing. Is it running in production versus is it running on your laptop or some CI server? That's one distinction, and the other is the reproducibility aspect.
Right. So that you can kind of go back and find the bug and fix the bug, and then so in a lot of ways, it sounds it's a bit more like unit or integration testing in the sense that it's a well prescribed set of tests that then you basically when you have introduced a new problem when you go to the next revision or whatever, which I think is software development component that is gets a lot of short shrift. We always like to write the first one, but having to maintain it over time is always much harder and nowhere near as much fun. Cool. So have you seen it's kind of the operators using it in the wild yet? Has it has it been around long enough? Have people been adopting the usage?
We've been getting like a trickle of reports from people who are not us trying to run the tool. So that's always promising. There's still more work that we need to do to make it easier to consume as well, right? Like, the ergonomics is one place. Again, like, we've been talking with Michael about this on what's the right way to, make it easy for anyone, say, using the operator SDK or controller runtime to just come generate a project, batteries attached, to start testing with Sieve, right? Like, so there's a bit of legwork there. So it's the least automated part of using Sieve, which is onboarding Sieve onto your project, right? So that's there's a bit of manual work that you need to do first, and I think once we iron that out, it'll get easier for people to adopt. But yeah, we are seeing the first trickle of reports coming in from people on us using it.
Do you think there's potential for building support for Sieve or for tools like it into things like the Operator SDK or some of the other toolkits that have grown up around building operators? And then second sidebar, kind of to both of you, and I hope, and it's something that'll be useful for the audience, is that we have so far in this discussion used two words interchangeably, or even kind of neglected the word controller. And I'd like to kind of draw out, like, what's a controller, what's an operator, how are they different when we talk about those two things, so that we can move from there to understanding and making sure that Sieve is something we would use with one or both of those two permutations of the controller concept.
Do you want to take the controller versus operator thing? Because you were always the one telling us that, Michael. So yeah.
Yeah. So the good thing is that whatever like type of software you're building, whether it's a pure or plain controller or it's a more advanced operator, Sieve works in both places, because at the end of the day, Sieve instruments Kubernetes API and client libraries and calls. And since both of these controller patterns, if I want to call them this way, they all use, client Go or controller runtime in some form, whether it's through kubebuilder or the operator SDK. Sieve would apply there as well. The test plans obviously might be more complex in the operator world, because if you have a system that does like backup, snapshots, scaling platforms, or like storage volumes, etc., obviously the test plans and that maybe even the time running these tests would be longer than in a very simple controller, which just spins up pods, right? But I would not draw any distinction there where Sieve would apply.
Mm-hmm. Funnily, I think everything we've tested so far is an operator, not a.
Yep.
Yeah. So it definitely works on that spec, on that part more, I would say, so far.
And maybe as a concrete example, Josh, I was working a lot with the RabbitMQ team over the last 2 years, mainly because Knative has this concept of a broker, and there are implementations of these brokers, and RabbitMQ happens to be one. And so we were heavily relying on the RabbitMQ operator. And so I don't know if it was Lalith or me, or maybe together, we were like, okay, maybe that's a good one to test and see how good the operator is written, or how well it is written. And one of the bugs we found was an interesting one, where under some circumstances, the operator, the RabbitMQ operator, would delete the wrong stateful set. Which would have been attached to a RabbitMQ cluster that someone deploys through a custom resource definition. And we found that bug through Sieve, and the fix was an easy one. It was just using a precondition during a delete, which a lot of people I've not seen using them in a lot of controllers and operators. But as you know, or might not know, when you create or update or delete objects in Kubernetes, you have this conditions field or options field that you can pass in these controllers. And not always, but often you can pass preconditions, which, for example, could be delete that object, but only if it matches this ID. And this patch was added to the RabbitMQ operator, and the team was happy that this was fixed, because it was a critical one if you delete the wrong stateful set, obviously, right?
There was another one with volume management, again with the RabbitMQ. Like, that was one of the most fruitful engagements with the team we've had. Like so Sieve found a bug, and then in response, they kind of redid how they go about volume management, because there were some bugs around incorrectly managing volumes there as well. And then they actually added a corpus of tests to exercise things the way Sieve would have done it, right? Like that was pretty cool to see as well. So yeah.
And so I wonder if there's some way, like I'm searching or trying to come up with a question that'll kind of draw out. There's a lot of ways I might test an operator that I built to like, even to directly adopting the example we've kind of been working with so far with RabbitMQ. Like, I'm going to manage some volumes, and the bug that you were just bringing up, Lalith. And there's a lot of ways I might test like that code base if that's what I'm writing.
Yeah.
What does Sieve do that's different that is the real key advantage here from like say any other like a different test framework that I might look at? Now in my understanding and the little bit I played with it, I kind of understand or at least have a clue about like I have something that can kind of predictively look at a bunch of points along execution and then instrument those points with different things that might happen in the underlying API I'm addressing. So I think that's somewhere close to the heart of Sieve. And I'm wondering if for me and for the audience, you could kind of close that circle and tell me exactly why is it like different from using a more general purpose to test toolkit or something that like I might have heard of in the past or be familiar with.
Of course, yeah, sure. So let's take this example of this any operator. It has a reconcile loop, right? And now when this loop runs, typically what you have is you'll have like, I don't know, this can be scattered across many files, thousands of lines of code, whatever, right? And there are many points in that reconcile loop where it's actually interacting with, say, the Kubernetes API or something external to the controller. And all actions of that nature are asynchronous. That is, you might create a stateful set, but then the pods corresponding to that stateful set, there's no guarantee that it'll arrive by the time this blob of code finishes or something, right? So everything related to how the controller interacts with the environment is what Sieve will perturb, right? And so Sieve perturbs an execution, like you give it a test workload to run, Sieve will run the test workload, and then when it's running the version with the failures, it'll perturb the execution in many ways. So one of the patterns we introduced is we basically checking if your code is making an assumption that your reconcile loop will always run to completion, right? It'll check for atomicity debugs. So in this case, what Sieve will do is it'll generate a bunch of plans where at any point that it can do it, it'll basically inject a fault where it'll crash the controller exactly after it executes one interaction with the Kubernetes API. So every get or every delete or every update, it'll introduce a crash, right? So this is one thing that you won't find any off-the-box testing framework that will do this for you. And in fact, I would say like most test suites that you can find in open source controller or operator projects will not do this type of crash testing, right? Now, crashing after every sort of client go interaction is one thing, but we also do more, right? For example, we'll also do this thing where we observe during the fault-free run which messages is the controller reacting to, right? And then we'll selectively skip some of those because controllers are supposed to be level triggered. They're not guaranteed to be, there's no guarantee. They're not supposed to assume that they'll receive every notification about the edges in your state changes, right? So we'll actually force out those hidden assumptions from your code by finding edges in your sequence and making sure that the controller doesn't see it, right? We'll simulate all of those kinds of conditions for you, which is not something that any off-the-box testing toolkit will do, and it's certainly not something people do by hand either. It just doesn't scale to anticipate all of those cases by hand, right? And we also, the hardest thing that we do is the stale state testing, where we simulate what happens when you get stale messages from the Kubernetes API, which is currently allowed. And there are ways around it, not all perfect, but yeah. But yeah, because Sieve will actually look at your execution and it will do the reasoning to rather than just sort of exhaustively try out every possibility in a very clueless way. It'll actually reason and say, okay, it looks like this particular message is only meaningful within this time frame. And that's exactly the time frame where it'll give you a stale message or something like that, right? It'll actually do these. So we do 3 patterns right now: atomicity testing, stale states, and the sort of level triggering versus edge triggering kind of states. So
it's a bit comparable to what Jepson is doing in the database world, like Cal Kingsbury and the team. They enforce, or well, they can prove that there are bugs in the system, but they cannot prove that they find all of them. And it's for me, Sieve is a is a tool that you would run for conformance or in a QA kind of context, because it requires more resources and time, obviously, than just running a unit test, as you already said, Joshua. But at the same time, it's I would also describe it as like the co-pilot, which looks across your shoulder and is like, well, you're violating rule number 5 of writing Kubernetes controllers, which is you're assuming order, or that you see all the events and all the stuff. It's like your co-buddy a little bit. And because distributed systems are so hard, and even understanding Kubernetes and all the semantics and how the libraries might change over different versions, like nobody's an expert in there. Maybe Tim Hawkins is, right? And all these smart people. But in general, I would say that every line of code that you write in a controller or operator is not bug-free. And so Sieve helps to discover those.
So can I ask a little bit more of a background question, which is, you've put all this effort into Sieve, right? Which, has a very narrow use case, quote unquote. Why is this investment in kind of supporting the development of operators such a good idea? What is it about operators or controllers in general that you think is so important that, I completely agree with you, Michael, testing distributed systems is a non-trivial exercise, of any kind. But obviously this particular space you found particularly compelling that you wanted to go and support this. So what is it about that space that you think is so interesting?
I think Kubernetes is a fantastic platform, and it's the excitement really comes for me from Kubernetes, the platform itself. But there's this nice thing that Kubernetes enables, and that most things running on a Kubernetes cluster is probably third party, right? It's not right. Like most operators, controllers, and control plane functions that come into any Kubernetes cluster is third party, and they all work pretty much off of the same core libraries, right? Like client Go, controller runtime, whatever, right? And that just means that if you have that nice vantage point to do this type of testing, and that's what we were able to find, that there is such a clean vantage point from where you can do this type of automatic testing. That means all these operators and controllers can benefit from one testing tool, right? Usually this is quite hard to pull off in an arbitrary distributed system. They usually have very bespoke, internal interfaces, which are you can put in a lot of effort and make that testable, but then there's no reuse potential. But with Sieve, we found that this clean separation of state and computation in a Kubernetes cluster allows you to do this type of testing. Like you can create this testing tool once, and a large part of the ecosystem can actually benefit from it, and that's why.
Can I ask to clarify a little bit? Because it certainly in reading material about Sieve before we join you folks today and we're having this discussion, I'm like etcd, which I'm really familiar with. My background's at CoreOS. I wrote a lot of the initial first couple of versions of etcd documentation, more or less well, to the extent I understood etcd, right? Where you just referenced to discovering a point where you could repeatably do this kind of testing. Is that point in the Kubernetes API, or is it based on underlying guarantees from etcd that filter up into that API? Can you help me understand why is etcd as important as it is to the background discussion of this? If I'm then largely targeting the higher level Kubernetes API when I'm doing the actual testing.
So from our vantage point, so from Sieve's point of view, from the testing vantage point, right? Like the Kubernetes core, the API servers and etcd is really just a database of objects. Right, so you run some workload. Let's say you run some. You bring up a Cassandra cluster, you tear it down, whatever. Like you'll basically see the at any point in time. If you look at the Kubernetes API or this database, right, you'll see some set of objects, and every little control plane action where you create, modify, or delete an object will give you a slightly different database, right? So there's this history or this trace of database states that you can always observe. And the ordering of this thing is important because it can't be the case that every controller is seeing a different order, right? It has to be one order shared across the entire system, and that's why etcd's guarantees are important there. But all we need to trace is basically at any given point in time when the controller did X, what was the state of this database, or what set of objects were in the API before or after each event, right? And so this point where the controllers are interacting with the Kubernetes API is also very simple semantically, right? You read, modify, or delete, or create objects, right? It's literally just a simple key value store from that point of view, which has very simple semantics, right? So we can actually, it makes it easy for us to reason about things like the lifetime of objects. I know if a delete went for a key X, that means X is no longer going to be in the API after this point in time. Like we can make these type of assumptions quite easily, unlike with, again, like an arbitrary distributed system. Like if you took Hadoop and tried to do this type of work, it's going to be very, very hard in comparison, because the semantics of their APIs are very hard and opaque. And you don't even know what are these objects going in and out of these internal APIs. It's very hard to make that type of guesswork. You don't need to. There's really no guessing involved when you're doing this inside Kubernetes, and that's what makes it this effective. Yeah.
So I kind of was curious a little bit more about kind of the operation in general. So, I mean, I guess what I'm also hearing you say, right, is that you think a major portion of the ecosystem for Kubernetes is and should be operators, whatever. And so anything we can do to kind of enable their creation and continued flow to exist, right, is better, for the Kubernetes platform, because that's a good delivery model for these systems.
Maybe I would add to this is that if you look at how Kubernetes has grown and been adopted across the industry, like every cloud provider, almost every software company is using or offering Kubernetes. It has come somehow this de facto API that is offered. And so for software vendors or ISVs, it's a nice nice platform to use, because you can just assume it's ubiquitous, it's always there, right? And one of the interesting projects that I've also been following is the KCP project from Red Hat. And I was having early discussions with Stefan Szymanski. He's one of the lead engineers there as well, and asking, because KCP takes Kubernetes, to the next level, if you will, like taking the core API principles and making it more than just quote a container orchestrator. And there, the same semantics apply. You use the same libraries or the same concepts, the same patterns are there, but you might do user management or workspace management, across the globe, if you will, but using the same Kubernetes API principles. And that means that the complexity of these projects obviously is increasing, and so will be the software quality and the bugs that you will find. And that's why I believe that Sieve can really help to change the game there in providing and writing better software on top of Kubernetes, because something that we don't really do quite well in IT and tech space, I would say in general, compared to other sectors like civil engineering or airspace, is like we are probably still in baby steps, and we're still crawling when it comes to the code and the quality of the software that we produce, like on average. Not everyone, right? But on average. But imagine I would just go out and start building a bridge and call it a day. That's probably not a good way to do stuff, right? There's way more regulations, way more descriptions and stuff that you have to put in place before you can actually start building the bridge. And in computer science, people like Leslie Lampert, they advocated for writing specifications first, something like in TLA Plus, write the specifications in a non-code like language, like use mathematics to write the algorithm, and then prove it, and then write the actual code. But often we just start writing the code, and then if it works, unit test passes. Sounds like it's good, right? And then these bugs just uncover. Some are more complex and subtle to expose, and some just come up and kill the workload. And that's why I think Sieve at least helps to write and create better software, especially as the Kubernetes adoption is growing.
Yeah.
So interestingly enough, plug our own show. When our first episode, when we interviewed Clayton Coleman, we talked about KCP, and I'll throw that link in the chat, like I've been doing a bunch of others. But I was kind of curious about, I think that kind of control plane idea, right, is that, kind of having a uniform API for all the things really does have, some serious advantages. I was kind of curious about, and specifically, you mentioned that, kind of Sieve is a dev time tool. is that what you foresee in the future? Is this something that should be kind of running in production? I mean, one of the things that I've found, so actually, I've been working on distributed systems for a long, long time, and even we actually, a friend of mine and I built a Visual Basic remote tool over HTTP and lied to it about it actually being DCOM. So this was a long time ago, right? And we actually wrote a way to be able to watch for distributed system kind of communication challenges as the application was running. So we also had a dev time tool, but we also kind of wanted to run it in production. So the hardest part about distributed systems is you put it in production, and all of a sudden you're like, I have literally no idea what the path of code that was actually traversed was, and by design almost. And so how can we help with that kind of tool as we go forward? Is that a different, is that Sieve Prime, or is that somewhere Sieve might want to go?
So far, I think we're doubling down on the development side thing, right? Like, I think I think you've hit the nail on the head there, right? Like, you don't know what path you took to hit a bug in production. And I think our philosophy here, at least, has been, don't even give a chance for a bug to happen in production if you can avoid it, right? And so we are even looking at things like verification right now, because again, Sieve is a testing tool. Its effectiveness is only as good as the initial happy path tests that you provide, and Sieve will explore all its conditions based on those initial tests, but it's not going to guarantee the absence of bugs, for which you need things like verification. On the doing things live side, I'm involved in some projects where we are looking, again, this principle of like, if all of your state is in one globally ordered database and you don't have any state off of it, say all state outside of it is ephemeral, it might help with doing some things like debugging. There's this project I'm involved in, it's called like DBOS. It's with collaborators from Stanford and MIT. And here we are looking into some of these type of questions on how can you attach a debugger to a live system and find out exactly what what was the state as of a bug happening. And if you can trace all of the information until then, right, like you can do things like record and replay debugging live, but it assumes a very different, like a very restricted programming environment, unlike what we're talking about with things like controllers and operators and more broadly, right? You have to restrict the programming environment in order to be able to do that cheaply. Otherwise, you're collecting all these stack traces and whatnot. Like, right, it gets much harder. So, yeah.
Oh, I totally understand. Yeah, I mean, so but I guess kind of what we should be looking for is kind of the breadth, increased breadth of Sieve's coverage around kind of dealing with these tool chains, with the hope that there will be fewer bugs in production. I don't know, maybe I'm less optimistic than you are. That certainly I have never had a production system that didn't have the occasional bug. So it's always there, but we can get closer, right? Every time.
Yeah, there's no such thing as bug-free software, even with verification, if you ask me. But you can. So there's going to be this quality curve, right? You can push at it, and you can change the. You can play with the asymptotics a little bit, but yeah, you're not going to hit zero. Exactly.
Yeah, I still remember in college I had a professor who told me that as I became more experienced, I would stop ever having syntax errors, and I was like, and X number of years later, like 25-ish, I'm still waiting for that day, for example. So bugs are a way of life, and it's more about being able to identify kind of why they happened, how they keep keeping them from happening again. The whole like blame-free culture and all that stuff, I think, is really, really important to good software.
I think one important bit here is also what is the cost of a bug, right?
Right.
It's I think tools like Sieve, I think, are valuable because the cost of a bug in this space is quite large. Like we are finding bugs where volumes get accidentally deleted and things like this, right? You're losing data. Right. There are also security holes that show up where there were some operators where we found that like a crash at the wrong time would cause them to silently not configure TLS. things like this, right? Like, so there is quite a price for these type of bugs, and therefore it's okay to spend a bit more, resources and development time trying to find them. For
Right.
other kinds of bugs where you don't have this much of a price, perhaps it's not. Yeah, these tools might be overkill, but I think this is the right space for this type of work.
Right. I really like that angle of analysis there, Lalith, because to the extent that we're using operators to manage the platform itself and foundation software that are pieces of every application we build above that surface, like it may not meet any of the technical definitions, but it is in fact tantamount to operating system functions and has the expense and the damage potential of flaws, bugs, and security vulnerabilities in an operating system surface. So if I'm somebody who wants to push on that quality curve, and I'm really interested in Sieve, so this is a two-part question. One, if I want to start using it tomorrow to make my operators better, what's the first thing I should do? Two, if I want to start working on Sieve tomorrow to make everyone's operators and controllers better, what is the first thing I should do?
So the first part is what should you do if you want to use it, for your operator today. If you go to the Sieve project, you'll basically find this porting guide on how to, bring Sieve into your project. And it also will answer your second question, because you'll see a lot of the work that you're doing by hand that could be, defaults that you get from, let's say, using an SDK directly, right? So here, for example, you'll see that you're going to specify a bunch of version info, like what Go version are you using, what Kubernetes version are you using, what commit ID are you using for your project to test, and so on. A lot of those defaults, I think, can come straight out of, like, if you integrated this with, say, the operator SDK, and there was some batteries attached way where you just say, generate this project to be Sieve enabled, a lot of those defaults could just come off of the project itself, right? And then, for example, Sieve needs some information like, oh, where is the Docker file for this project? Or where is, it also needs some information on the CR itself so that it can put in some annotations that Sieve will use during testing to find the pod corresponding to the controller. Like, a lot of these things can just really be, it's mechanical work that I think we can automate away if we actually wrote this as a plugin for, say, I don't know, controller runtime or operator SDK or something like this. So this is, if you go through this process once, especially this crowd, you'll see exactly why there's a strong need for us to integrate this with one of these SDKs. A lot of those defaults and things that you're hard coding into a manifest file that Sieve will use can just be assumed easily, right? Yeah. And if you want to help us with the Sieve project, again, this is one of the main things that we need. Like, I think Shudong is working on a wish list that will be up soon, but I think ergonomics around making it easy to consume it in any project is the big thing for us right now.
And when that wish list is done, where do you expect it to be? Is it like a set of GitHub issues or like its own doc, or?
It'll be both. So
Okay.
there'll be a pinned issue, and either it'll be self-contained there or there will be a doc for it as well.
Okay. I linked the project and the porting guide in the chat, so people should be able to find it. So that's cool. Josh, did that answer your question? Did you have another question you wanted to ask about it?
No, I think those are exactly kind of the two things I'm was looking for, and especially delighted by the observation that in a crowd full of people looking for SRE surfaces to automate, as soon as you encounter the first order problems of manual work, you'll go looking to how to make them not manual the second time you go through.
Yeah.
Yes. The key to being a good programmer is being lazy, right? The lazier the better. Actually, we're just about out of time, so I wanted to maybe take this opportunity to say, were there final thoughts or final questions or anything that you wanted to bring up to either Lalith or Mike?
What's the next big exciting feature that we would expect to see in Sieve? If I wanted to give a 5-minute lightning talk tomorrow, I think I could get through the first 3 minutes. Here's what it is. Here's why you should care. What's my hook to walk out with? Here's the next great thing about it. Would it be integrations with build toolkits and SDKs like KubeBuilder and Operator SDK and some of those things we've talked about. Is any of that work active? Like, is there some of that going on that we could take a look at now? Or
I think the one big thing that we're working on now is even not needing the assumption that, for example, right now we assume controller runtime. I think we're working to remove that assumption and work with just base client Go. And once we do that, it gets easier to sort of go upwards as needed for the different other frameworks that show up, right? So this is one big thing we're working on now. I would say going forward, if the community would like to help us out, I think integration with all of these frameworks, as you mentioned, is the big thing that we need to address. But this is something we would really appreciate some help on. And this is basically a big call to arms, I would say, right? Like, to come help us with this project. The long-term thing to get excited about is that we're looking at Sieve as not just something to test controllers or operators, but also like what part of this can also extend all the way to the applications that are being managed by these operators, right? So we don't have any visibility into, let's say, what the Cassandra cluster itself is doing today, right? That the operator might manage. Is there something that we can do to also make it easier to do this type of testing one level past the operator? Is something that we're quite excited about. So that's something to keep an eye out for. Yeah. So expanding the scope of this type of testing.
And maybe something for the community would be, because Sieve found a lot of bugs, and some of them or most of them were already closed or there's remediation. I think at least maybe presenting at KubeCon about the bugs discovered and how to remediate would be a good talk, because there's not been a lot of Kubernetes controller related talks lately, but the ones that were presented, they were highly attended by a lot of folks out there. And there's not, even though there's two good books that I know of, Josh, you wrote one, and Stefan Szymanski and Michael Hausenblas wrote the other one. But I think more on this, I called it the mental, the mode that you have to have in your head, or the mindset of writing these controllers. There's a lot of things, like maybe the 5 or 10 golden rules that you have to keep in mind. And relating it to like best practices and writing these operators and stuff like that. I think sharing the knowledge, the learnings from the Sieve projects is also going to be very helpful. And then obviously driving adoption of Sieve, because people are getting aware of Sieve.
Cool. Yeah. Those are great things to look forward to. And I'll take that as a little bit of a segue, in that I'll actually be doing an interview or a panel discussion with Ford at KubeCon in North America in Detroit in October. And we have a bunch of other crazy ideas planned. So as KBE Insider, so you should definitely join us, as well as we'll be doing a kind of a meet and greet event at the OpenShift Commons, a reception the day before. So definitely join us there, and watch for the video output of, and I'll give you the teaser of, maybe riding around in cars interviewing people, because it is Motor City. And then next time on the show, at the end of September, so the last Tuesday of September, we're going to be interviewing ICUS about Knative and ChainGuard, and so talking about.
Oh, Ville is going to be there. Oh, that's going to be great. Nice. Yeah. Say hey.
Awesome. Yeah, and obviously, I'm a little biased towards it anyway, because I think serverless and event-driven architectures are really the way all software development should be done.
They are.
Yes, I'm a little biased. But thank you so much for being on the show. We really appreciate it, and we look forward to seeing you again. Thanks, everybody.
Thanks a lot for having us. Yeah.
Thank you.
Thanks very much for joining us, folks.